Hello everyone, I'm Lakmal, a PhD student from EPFL and a research assistant at Idiop Research Institute, Switzerland. Today I'm going to present our work on the topic One More Bite, Inferring Food Consumption Level of College Students Using Smartphone Sensing and Self-Reports. Many young adults show a tendency to adopt unhealthy eating practices during college years when they undergo significant lifestyle changes. Unhealthy eating habits at this age could lead to adverse health outcomes in the long term. Due to these reasons, researchers in nutrition, behavioral science, and psychology are extensively studying causes and contexts of food consumption, especially among young adults. Prior research in these domains have linked factors such as the social context, eating location, availability and types of food, psychological aspects, and concurrent activities to the food consumption level. So if we talk about mobile health applications, after fitness tracking, food and nutrition has become the second most popular type of M-health applications. Many widely used commercial apps allow users to keep their food intake as a mobile food diary, providing basic statistical insights so that people can adhere to healthy eating patterns. However, in the current states, mobile food diary related studies and research are primarily based on self-reports and do not yet make full use of smartphone sensing capabilities. So another underexplored area is how we can combine mobile food diaries and passive smartphone sensing. If we talk about food consumption level, there are subjective as well as objective interpretations. The objective food consumption level attempts to capture the exact calorie consumption during eating episodes from a purely nutritional science standpoint. Many currently available mobile food diary-based studies attempt to capture this attribute using self-reports by requesting the user to enter each type of food and the amount they eat. However, these techniques might not be accurate due to a range of individual as well as measurement factors. Further, nutrition researchers have also widely used subjective measures to capture food consumption levels of people by considering the psychology of eating, also known as self-perceived food consumption level. This view is primarily based on the idea that when you ask people whether they overate or not, more often than not, the answer would be based on an eating episode level and the self-perceived amount of food they have eaten. A lot of prior work in nutrition science support this view regarding food consumption level. So in this study, we also used the same subjective food consumption level. So participants self-reported their food consumption as overeating, eating more than usual, undereating, eating less than usual, and eating as usual. Considering all these aspects, we asked two research questions. Number one, what behaviors and contextual patterns around food consumption levels can be observed by analyzing everyday eating episodes of a group of college students obtained via passive smartphone sensing and self-reports. Then number two, can the self-perceived food consumption level be inferred using contextual data obtained through a mobile application? So the diagram here shows our study objective, that is to leverage findings in nutritional science and mobile sensing research in order to do the food consumption level inference using smartphone sensing features. So to test our hypothesis, we conducted a new mobile data collection campaign in Mexico with 84 college students to capture their eating behavior, including food consumption levels. During our study, we collected 3,278 self-reports. In addition to self-reported data, we collected passive smartphone sensing data related to eating context, physical activity levels, and phone usage to characterize eating episodes in a holistic perspective. So as a summary, with self-reports that are similar to a mobile food diary, we captured eating episode level data about food categories, mood and stress when eating, and also contextual information about the activities, social context, and semantic location. Then we also manually crafted features using passive smartphone sensing data by considering a time window of 1 hour around eating episodes. So this is a result from a descriptive analysis. Results show that participants reported more overeating as compared to undereating when they ate fats and oils, meat and sausages, sugary juices, and prepared dishes from restaurants. This result shows that when participants were in a more social setting, they were more overeating as opposed to undereating. And when they were commuting, there were more undereating episodes as compared to both overeating and as usual eating. Further, participants reported overeating more often as opposed to undereating when they were in positive moods. In a statistical analysis, we calculated t-statistic, p-value, and coherence t for all the features. Results show that features from food diaries, such as the social context, some food categories such as fats and oils, and also mood and stress while eating can help in discriminating between different food consumption levels with a high statistical significance. In addition, passive smartphone sensing features from the accelerometer, app usage, and screen usage too showed high statistical significances when discriminating between different food consumption levels. Finally, we defined and evaluated a novel Ubicomp task by inferring eating more than usual, less than usual, and as usual episodes using passive smartphone sensing and self-report data with an accuracy of 87.81%. We evaluated more than 6 different models and different feature group combinations and got best results with random forest classifiers with leave k users out strategy. Further, we show that the same inference task can be done with an accuracy of 83.5% by only using smartphone sensing features and time of eating. So the results from our study illustrate the potential of using passive smartphone sensing alone or together with mobile food journals towards building context-aware food-related mobile systems. Thank you very much.